So the first question was calculate the weight, was it? Yeah. So you have A part 1, density equals mass over volume. So mass equals density multiplied volume, which is equal to 850, 1.2, 0.3, 0.04. So the mass is equal to 850 times 1.2 times 0.3 times 0.04. So what did you get for the mass?
120,744 newtons.
What did you get for the mass?
Oh, mass.
Yeah, listen to me, please.
122,490.
Thank you. 12.24 kilograms. Yes. So, what's the formula for weight? mg. So that would equal 120.07, which is equal to 120 newtons. Yeah? Yeah. That's the first part, isn't it? Yeah, okay.
Centimeter is -2, right?
Yep. Next part? Yep, okay. So what they do now is, here is the shelf, and I think there's two brackets here, or and S, and you know, what's this distance? What did they say it was? 15 centimeters? Yeah? And then, do they, and also actually, you know, there's 120 newtons here, and there's something on the shelf, isn't there? Where is it now? It's placed 40 from A, and it's 5.1 kilograms. Okay, so it's 40 from A. And 5.1. So 5.1 times 9.81 is it's big. It's 50 newtons. You actually know this distance here. What's this distance to the weight? 60 centimeters. And lastly, what's the distance to the S here? 105 centimeters, yeah. Okay, so we shall make our two equations now. You can say R plus S, what should that equal? 170. True? Yep. Okay. Then what you can do is do your turning point here. So this one is clockwise, and this one anti-clockwise. So you have, yeah, now it's a bit, the distance, maybe I should have measured my distances from R actually. So how big is this distance? Here to here?
40.
Is it 40?
Yeah.
I don't. 55. Oh, it is 40 because that's. They tell you that in the question. Yes, Amanda? You can ask me. Or Fahad.
It's 50.
this plus this.
It's not the 55 centimeter plus 105 centimeter.
For this, no, this is the up force equals the down force. So up equals down, down. Is okay, Amanda? Alright. What's the distance here?
40.
40. And what's the force? What's this force? 50. Okay. Now what's the distance from here to the center?
120 minus 65.
What is it?
What,
From here to the center.
5.
No.
45.
45, because here to here is
6.
60 and here to here is 15, so 45. And the force is 120.
Yeah, 45.
And then from here to here.
50.
No.
Which way? Okay, not this.
Here to here.
30 minus 90.
90.
90. And the force? What's the force here?
B.
Well, what letter am I using?
S.
S.
Oh, sorry, S.
Something.
Yeah.
We can solve this question in 2 parts.
Yeah.
Okay.
Is it clear how I made those two equations? So this one here is the up force equals the down force, and this one here is the clockwise equals the
And
anti-clockwise. Okay? Amanda, does this make sense? You're confused? 0.4? It's the distance from here to here. So maybe if I draw it again, or maybe if I go back to this here. Look up. 0.4 is the distance from here to here. Then the next one is the distance from here to the center. And then the next one is the distance from here to B. They're my three. Which one's equal? A,
A to
the center,
A to center plus A to the bottom
A to B.
is equal to
Yeah, the distance from A to the center is half the distance from A to B.
yes.
Yeah. So what are you asking me?
Why is
Why is what equal?
it's balanced.
equal?
Why is it equal? We know that the weight will always be in the center. It's the center of gravity. So if you had something like this, the weight is always in the center.
It is
So it's in
balanced.
the middle. And you also know here is 15 and here is 15. So it'll be nice and balanced. The weight will be right in the middle. So here to here is 60. Here to here is 15. So here to the center is 45. And then here again is another 45. So the total is 90. So you have 40, 45 and 90 as the three distances. Which you can see here. 40, 45 and 90. Here to center, sorry, here to base, here to center, here to end. 40, 45, 90. So I can get the S now. Okay. So that means the S is equal to 60.22 newtons. No? Well, double check. Oh no, it's not. It's 82. 82.22. And then what did you get for the ore?
87.
Yeah. And the ore is 87.78 newtons. So this is the answer for ore, and this is the answer for S. Yes, Grace? No question?
Yes.
What's the question? Y is equal to, yeah. So look, if you have something like this, let's say, okay, so let's just say here is ore, here is S, and here is T, and let's say this here, and then here to here, let me call it X, and then here to here, we'll call it Y. So the clockwise would be this one. So it's this distance, which is Y, multiply this force, which is T. And then the anti-clockwise will be this one, which is this distance, X, multiply this force, S. And they should be equal. This is the idea. This is your question. This is the lesson we did. I'll tell you the name if you want to watch it again. It was this lesson in mechanics. These two. So principle of moments, and also the cantilevers. Oops. You remember this one? That's the lesson. Yeah. Okay, can we go to the next part of this question? Wait. You want me to go back here? Here? Ah, no. That's just rough ideas. No. Okay, the next part. So let me pause this. Okay, so, here's my picture. It's beautiful, isn't it? So what's happening here is the cannon is fired horizontally at 80. And they want to know the time. Is the time the first part?
Yes.
And the distance on the ground. So that's, do you remember the name of that distance, KJ? Range. So they want to know the range, and they want to know the time. So should we look at X or Y? No. First Y. So look at the Y first. So what's the U?
0.
Yeah. V.
No,
A.
9.81.
T. Don't know. And S, actually, did they tell us the S in the question?
Yeah, minus 28.
It's 28 meters, is it?
So it's minus 28.
Yeah. So S is minus 28. So we can use the formula, which one will we use? S equals UT plus a half AT squared.
80 cancels.
So minus 28 equals minus a half
9 point
9.81.
T squared.
Yeah? So T equals, let's check it.
2.389.
28 times 2 divided, what did you get?
2.4.
Let's double check.
Yeah, almost 2.4.
2.39.
Yeah.
Yeah, 2.4.
I'll keep it as 2.389. Okay. And what did they want for the next part? The range, yeah? Which is Sx. Now, if you look in the X, I'll write it here. UVATS. What's the U? 80. The V, don't know. A,
0.
0. T,
The same
2.389. S is what you want.
Yeah.
So we can use the same formula, UT plus a half AT squared. But that's gone. So you get range equals UT. So just multiply your answer by 80.
191.439.
By 80?
Yeah, because the speed is 80. It's UT, the formula. True?
Yeah.
No, I know you know. I'm asking KJ because he was confused. Yes. What's confusing you, KJ?
You want to find the distance.
Yeah.
It's not going to be U plus V over 2 times.
No, just use the formula you did a minute ago. UT plus a half AT squared.
Okay.
The A is 0,
Okay.
so it's just UT.
Okay.
Yeah. So yes, it'll be 191.1 meters. So that's the answer for or, and that's the answer for T. Okay, the last part is, what's the last part? The energy when it hits the ground or something?
Kinetic energy that strikes the ground.
Oh yeah, the energy it strikes the ground. Okay, so here, what energy does the ball have up here? Potential and actually kinetic, because it's moving. Did you forget about the kinetic part? Yeah. And what energy does it have down here? It only has kinetic
When it hits.
when it hits. So you can say M, what's the M actually? 6.4. Well, I'll write it down. mgh plus a half mu squared equals a half v squared. So 6.4, 9.81, 28 plus a half, 6.4, 80 squared equals a half. Oh, actually, that's what you want, isn't it?
Yeah.
You want to know what this is.
Yeah.
Equals KE. Okay, so let's just calculate that. So, let's see. 6.4 times 9.81 times 28. So that's 1757.952 plus plus 20480. That's equal to the kinetic energy at the end. So the kinetic energy at the end is 2223, yeah, so we'll round it up, 38 joules. So that's how much kinetic energy hits, oh, I don't know, that can be KJ maybe, or who would I like to hit with a cannonball from the top of a building? No, I need to
like this.
I need to have a think about this one. I don't want to waste it. Okay, can we do the last part? Yeah.
At the top, it was like when it stops, it just had potential energy. When
Yeah.
it's, when they start
Yep.
shooting.
Yep.
while then it has formation and kinetic energy.
Yes, after it is released from the
Yeah,
cannon.
after this.
Mm.
So you're just measuring the value after releasing and
After.
before it hits.
Yes, correct. Okay.
That's how I got from.
You didn't put in the kinetic, yes. So your answer is too small. It's okay, Grace?
As usual.
What was her question, Sophie?
No question now. I have a question also.
Yeah, no, I know. I was asking Sophie what your question was. You.
No.
No.
No question now.
No, I'm not going to. Alright, the last part. The real answer, they say the real kinetic energy will be less than 22238 joules. And the question is why? Does anybody know? Yeah,
The other resistance.
the air slows it down. So where is the energy lost? What does the energy change into? Very good, yes, very good. So some kinetic energy will be converted into heat energy.
We have formation.
Hmm?
In the last we have
It is there? Okay. Yeah? Okay, let's look at another